All right, welcome to another video. This is Mr. Campo from China. And today we're going to look at quadratic equations, okay? This is going to be a long video. All right, so quadratic equations, my hand drive. Remove this quadratic equations. So they're going to look something like this, okay? A times x squared plus bx plus c equals to 0. Then you factorize this, or you use, there's different approaches you can use. You can factorize it. You can use the quadratic formula. You can use completing the square, right? We can factorize, use the quadratic formula. Actually, you can always use the quadratic formula to check your answer. But if they specify you have to factorize or you have to complete the square, so you have to follow directions, right? Complete the square. All right, so let's get into some basic quadratic expressions. 3x squared minus 2x plus 1. So this 3 would be our A, this negative 2 would be our B, and this 1 would be our C, right? A equals to 3, B equals to negative 2, and C equals to 1. Now, this is important because you're gonna use these values A, B, and C for the quadratic formula, which is gonna come up later on. Also, if we want to find the vertex, if you have a quadratic equation and you want to find the vertex, so the vertex is this point right here. This looks more like a quartic function, but yeah, the vertex, right? And this is gonna have the coordinates h and k. So you're gonna need to be able to identify the A, the B, and the C. Okay. All right, let's do another one. X squared plus x minus 2. So A equals to 1, B equals to 1, and C equals to negative 2, right? All right, what about this one? 1 minus x squared plus 3x. Take a moment to think about it, right? So A equals to negative 1, B equals to 3, and C equals to 1, right? The leading coefficient is going to be the one with A is going to be the leading coefficient, right? Bx plus C. So that with the x squared variable, that's going to give you the value for A. So it's right here. So they may not always give it to you nicely organized in descending order. Sometimes it might give it to you mixed up like this. Okay. Okay, so yeah, just remember that they will not always give it to you in descending order. They might give it to you mixed up. Let's see another one. This one, 4 minus x squared. Our A equals to negative 1, right? Our B equals to what? 0, and our C equals to 4. Okay. And lastly, square root of 2 times x squared minus 3x. All right, so our A equals square root of 2, our B equals negative 3, and our C equals to 0. All right. Okay. So again, if they give it to you in this form, ax squared plus bx plus c equals to 0, this equation is a general quadratic equation, okay? All right, and then like I said before, you have to use different methods, factorization, completing the square, or the quadratic formula. But again, remember, like I said before, Regardless of which method they ask you to use, always, you can always rely on the quadratic formula. I'm gonna write it down in case you forgot it. X equals to minus b plus or minus the square root of the discriminant, which is b squared minus 4 times a times c divided by 2 times a. And this will always give you the values no matter what quadratic equation you get. You can always plug in these a, b, and c, and you will get the roots. Okay. uh, let's take a look at the square root method first. That's an ugly one. Better one? Yes. Square root method. All right, so if they give it to you in this form, a times x squared plus c equals to 0, and c, a does not equal to 0, right? And c is less than or equal to 0. All right, so, example like this, right? So we know a is 1, so it's not equal to 0. C is less than or equal to 0. And then to solve this, we're just gonna isolate our x. So we add 4 to both sides, and then this will cancel out, and we get x squared equals to 4. And now we take the square root of both sides, and we're gonna get x equals to plus or minus the square root of 4. And this is the same as x equals to 2 or x equals to negative 2, right? So that's the square root method. That was right. Oh, come on. All right, let's see. Let's do another one. Oh, come on, no water. Sorry about that. Got something on my tablet. Okay. Let's see. A x squared minus 16 equals to 0. So we isolate our x. This becomes 0. X squared equals to 16. We take the square root, and then we get x equals to plus or minus 4. So those are going to be the the roots, right? The numbers are, yeah, the roots, the numbers that are going to make this equation 0. Okay. So 4, 0, and negative 4, 0. Okay. All right. Yeah, x 4, okay. B x squared equals to 7. So we just take the square root of both sides, and we get plus or minus the square root of 7. That's it. That'll be the answer, right? C, 2x minus 1 squared equals to 25. All right, this one, we can start by taking the square root of both sides. Come on, let me see. Is there a way to go back? Come on. No. Okay, so if I do that, this is gonna be isolated, 2x minus 1. The square root of this is gonna be plus or minus 5, right? Okay, so I plus 1 equals to 2x plus or minus 5 plus 1, and then divided by 2, so x equals to plus or minus 5 plus 1 divided by 2. So what do we get? We get 5 plus 1 divided by 2, right? So 6 divided by 2 equals to 3. And then the other one would be negative 5 plus 1 divided by 2. So that'll be negative 4 divided by 2 equals to negative 2. And those are our two answers, 3 and negative 2. Okay, the 2x squared plus 5 equals to 0. And now remember that a has to be from here. Well, where is it? A cannot equal to 0. And c must be less than or equal to 0. And this 5, is it less than or equal to 0? No, right? It's not. 5 is more than 0. So that's going to give us non-real numbers, you see? We're going to get this right here, isolating our x. Equals to negative 5. And then I divide it by 2. And I'm going to get negative 5. And then I take the square root of both sides, and I'm going to get x equals to plus or minus the square root of negative 5 over 2. And that's not a real number, right? Not a real number. Let me write number. That's too lazy. All right, and we only deal with imaginary, well, we only deal with real numbers. This would be imaginary number, right? This would be an imaginary number. All right, factorization. So now we're gonna look at factorization. When you can factorize this, right? A times x squared plus bx plus c. And what you need to do is you need to find two numbers, right? Pretty much this, two numbers, let's say m, two integers m and n, right? Whose product will give you c, right? Not 5c. You see, and then whose addition, right, will give you b. That's it. That's what we need to find when we use factorization. Also, we have to use the principle that if a times b equals to 0, then either a equals to 0 or b equals to 0, or both, right? All right, so let's look at some factorization problems. X squared minus 16. So this is a difference of two squares, right? So this could be factorized as x plus 4 times x minus 4. All right, now we have it factorized. I was equal to 0, my bad. I forgot that, equals to 0. Okay, so the two answers are x equals to negative 4 and x equals to 4. And voila, that's it. B, 4x squared plus 3x equals to 0. So I can factorize an x, right? X times 4x squared, and then this, we needed 3, right? Plus 3. X times 3 is equals to 3x equals to 0. Now, either x equals to 0, this equals to 0, or both equals to 0. So our x equals to 0, and then I can set this 4x plus 3 equals to 0, and I can isolate and solve for x. So I'm gonna get 4x equals to -3, and then x equals to -3/4. All right, let's take a look at a few more. C 2x squared plus 5x minus 12 equals to 0. So first thing you want to try to see if you can break this middle term into two other terms with x in them, which are going to help you group and factorize. If not, the alternative approach is to multiply the leading coefficient and the last number, and then that'll be uh, -24. And then you want to find two numbers that whose product is -24, but the addition is 5. Okay, and those two numbers would be, let's see, two numbers that when I multiply them I get -24 would be a times -3 equals to -24, right? And if I add these two up, 8 minus 3, I get 5. So these are my two numbers, 8 and -3. So I'm going to rewrite this as 2x squared plus 8x minus 3x minus 12 equals to 0. And now I want to factorize this, and then I'm going to group first. I'm going to group these two and these two, and then I'm going to factorize them. And you're gonna see how that's gonna help me simplify this expression and find the answers that I want. So if I group these two here, let me use a different color, just to for fun. And these two here. So from here I can factorize 2x, right? Plus 4. 2x times x, 2x squared. 2x times 4 times 4 is 8x. From here I can factorize -3. So this is x, -3 times x, -3x, and I need a -12, so this has to be positive for me to get -12. -3 times 4 is -12, equals to 0. Now we got x plus 4 in common, so I'm going to go ahead and factorize that, factor that out. 2x minus 3 equals to 0. So this is 0, or this is 0. So I set up my two equations. X plus 4 equals to 0, so x equals to -4. Or 2x minus 3 equals to 0, so x equals to 3/2. Okay? All right. Let's do one more. All right, so I want to do D. I want to redo D because I checked the video that I made and it was missing something and it was a little confusing. So D says x over 2x minus 3 minus 1 over 3 minus x equals to 1. So first I want to take care of this side, right? I want to combine these two fractions, all right? And for me to be able to do that, I need to write them with the same denominator. All right, so the same denominator for that is going to be 2x minus 3 times 3 minus x. And then set it equal to 1. So I divide this by this, and I get 3 minus x times x. And then I divide this by this, and I get 2x minus 3 times 1. All right, then I can take this and multiply by 1, right? So, and I can combine these, so I get 3x minus x squared minus 2x plus 3 equals to 2x minus 3 times 3 minus x. Okay, let's double check. This is 3x. This is negative x squared. This is negative 2x. This is positive 3. I can combine like terms and I get 5x, 3 and 2x. Oh, no, not 5x, my bad. 3x minus 2x, that'll be 1x. All right. Minus x squared plus 3 equals to, this would be 2x times 3, that'll be 6x. 2x times negative x, that'll be negative 2x squared. Negative 3 times positive 3 is negative 9. Negative 3 times negative x is positive 3x. All right, now I just have to combine like terms and reorganize all of this. Okay, so this would be, let's see, I want to put my x's, my x, my my pronumerals, my x variables on the left. So I'm gonna add this here, subtract this here. So plus 2x squared minus 6x. And then I got, well, actually, I skipped one step. Let me just do this over. I have to combine like terms on this side. So I'm going to get x minus x squared plus 3 equals to 9x, right? 9x, 6x plus 3x, 9x minus 2x squared minus 9. Now I can go ahead and put my x's on one side and my numbers on the other. So let's see, that'll be plus 2x, right? Let me just write it here real quick. All right, so this will come, well, hold on. This is a quadratic function, so I want to set it equal to 0. So I want to bring all of this to my left-hand side. Yeah, because I want to set it equal to 0, right? So I can, like this. So I can solve for x. So let me just do that. I'm gonna bring everything to the left-hand side. So let's see, plus 2x squared minus 9x plus 9. So that'll be plus 9 plus 2x squared minus 9x. So this will be 0, this will be 0, 0. And then here we get minus 8x. And then we get plus x squared, right? And then we get plus 12. Okay. So now we got x squared minus 8x plus 12 equals to 0. Now I can factorize this as x minus 6 and x minus 2 equals to 0. Negative 6 times negative 2 is positive 12. Negative 6 and negative 2 multiplied together will give you positive 12. Negative 6 and negative 8. So sorry, negative 6 and negative 2 added up will give you negative 8. And then you just solve for the variables and you get x equals to 6 and x equals to 2. All right, so I just wanted to do this because it was a little confusing in when I first recorded it. So yeah, now it should be better. All right, let me stop right now. All right, so part 3, solving problems with solving word problems using quadratic equations. So let's see this. All right, so number 5. Let's see. Is it clean? It is clean. Number 5, we can start easy. The product of two. Oh, maybe I can type it, right? Let's see. Nega, nega. Mhm. Okay, let's see. The product of 2 and the square of x minus 3 is equal to 200, period. If x is a positive integer, comma, form a quadratic equation and solve it to find the value of x. The product of 2 and the square of x minus 3 is equal to 200, is that right? If x, I don't know why I didn't get, if x is a positive integer, form a quadratic equation and solve it to find the value of x. All right, let's just add a little something here, parenthesis, for this. So this is the product of 2, number 2, right? This is number 2. And the square of x minus 3. So 2 times x minus 3, that means the product. The square of this would be this, equals to 200. And that's it. That's a quadratic equation, right? Yeah. And it says x is a value of x. X is a positive integer, so x must be greater than 0, right? Positive integer. Oh, like 0 is not a positive integer. We got positive integers, negative integers, and 0. So x is greater than 0. So let's just solve this. We can divide everything by 2, right? And then we get x minus 3 squared equals to 100, right? Next, I can take the square root of both sides, and I'll get x minus 3 equals to the square root of 100 is plus or minus 10, right? And next, I can add 3, so x equals to plus or minus 10 plus 3. So we're going to get two numbers, right? We're going to get 10 plus 3, which is 13. And the other one is going to be negative 10 plus 3, which is negative 7. Now remember this, x is a positive integer, so we have to reject this one. Reject. And we are left with x equals to 13 right here. Okay. Next. Let's see. Oh, how do I make it bigger? Oh, the size of the, mm, is it? Size of the font. Hmm. A rectangular area can be completely tiled with 200 square tiles, period. If the side length of each tile is increased by 1 centimeter, comma, it will take only 128 tiles to tile the same rectangular area, period. Form a quadratic equation and solve it to find the side length of each tile. Let's see if I got it all right. Hey, not an A. Oh, A like A. I got an email. A rectangular area can be built with 200 tiles, square tiles. If the side length of each tile is increased by 1 centimeter, it will take only 128 tiles to tile the same rectangular area. Form a quadratic equation and solve it to find the side length of each tile. So let's see. We have a rectangular area. So it's going to be the same area, right? And we're going to have, it's going to have square tiles. Well, 128, right? 200, yeah. For this one, it's 200. So let's say, we have my square tiles. Again, I'm not gonna get 200 tiles. It's just to give you an idea. Let's say I have 200 tiles, right? Okay, so I take out one of these tiles because it's a square. Actually, I can use a better square for this and a better rectangle, but I already did it. Which one is this square? This one? Let's see. Nice, very nice. High five. So I'm gonna need two squares for the other one. And actually I'm gonna need two rectangles. This one is crappy, but I'm gonna leave it there because I already made it. I already drew it. All right, so this one, it says the area, so the area of this rectangle, right, is gonna be the same, right? Let's say area one is gonna be the same as 200 times the area of each tile, the area of each tile, right? So I have 200, and if I calculate the area of each tile, which is going to be x squared, I use x here. That's going to give me the area, right? Once again, I got 200 tiles, square tiles, and the area of each one is x times x, right? If I let the side be x, and that's the one, that's what I need to find, right? The side length of each tile. So I start here and I'm gonna let that be x. And then for this one, a sub 2, it says the same rectangular area. It's gonna be the same. These two are the same areas, okay? And it says, if the side length of each tile is increased by 1 centimeter. So if I do same, well, that's gonna be bigger actually. Let's see. Let's make it a little bigger. All right, so if we increase it by 1 centimeter, right? X plus 1. It says that this would be, we can use 128 tiles. So the area will be given by 128 times x plus 1 times x plus 1, right? Because the area of this would be x plus 1 times x plus 1. The same way we have the area here as x times x, right? So x squared, and here it'll be x plus 1 squared. So that's why I wrote it this way. And this can be simplified as 128 times, what? No. 128 times x plus 1 squared. Okay? So we have our two equations, right? Or it's just one equation, but these two are the same. The area of this is the same as the area of this, right? I should have used this rectangle looks bigger, so I want to make it look a little smaller, just like the other one, right? Because they are identical. We're just changing the size of the tile. And okay, so what we can do is we can set these two equations equal to each other. So a sub 1 equals to a sub 2, which is the same as 200x squared equals to 128 times x plus 1 squared. So I have to isolate my x and yeah, find the value for x. So I can start by dividing by 128, right? How much is that? 200 divided by 128 is 1.5625. I guess we can do it that way. Also, well, actually, you know what? Let me do it. There's different approaches to do this. What we can do is multiply this out and then find Factorize it, okay? So let's do this. Let's multiply this out. So I'm gonna get 200x squared equals to 128 times x squared. This is x squared, 1x, so it's 2x, right? Plus 1. Then I, distribute that 128, so I get 200x squared equals to 128x squared plus 128 times 2. That'll be 256x plus 128. And now I can just I bring all this to one side, and then I'm gonna get 200x squared minus 128 x squared minus 256 x minus 128 equals to 0. So after I combine these two and I simplify this is going to simplify to uh, 72x squared minus 256x minus 128 equals to 0. I haven't simplified it yet, my bad. I haven't simplified it. All right. And then now I'm going to simplify, okay? I'm going to divide by 8. All right. So if I divide by 8, I'm going to get 9x squared minus 32x minus 16 equals to 0. So now I have to factorize this. And this, remember, you can multiply these two numbers, right? And then find two factors of that. So we got 9 times negative 16, negative 144. Okay. I'm gonna know for 4. 144, and then when I add them up, I get negative. Fuck, let me stop right now. All right, so those two numbers are gonna be, is it recording? Yes. Negative 36 times 4 equals to negative 144. And if I add up these two, I'm gonna get negative 32. So that's what I need to do here. 9x squared minus 36x plus 4x minus 16 equals to 0. Then I can factor out factor out the 9x. It'll be x, 9 times 9x, 9x times x equals to 9x squared, negative 36x, so I need to multiply it by negative 4. Here I can factorize the 4. So I get x, 4 times x is 4x, and I need a negative 16, so I need a negative 4 equals to 0. Factorize that x minus 4 times 9x plus 4. So x equals to 4, and x equals to negative 4 9s. Okay. And well, we're talking about length, right? So this we have to reject because we don't have negative numbers. We don't use negative numbers when we're talking about the length of something, right? So x equals to 4. Let me just go back. So it'll be, this would be 4, right? This will be 4. This will be 5. 4 plus 1 is 5, right? All right. So that's it. So the one for this is 4. The side length for this one is 4. When you use 200 tiles, when you use 128, you make it 5. Okay? Now we have a problem with let's see. An importer, let's see, let's try this. Oh. An importer sells a brand of disposable cameras to retail shops. So we're dealing with cameras. The weekly supply and demand equations are supply and demand equations. Supply and demand equations. So if you don't know what supply is how much people are willing to buy. No, I'm sorry. Supply is how much the seller is providing at his store, and demand is how much people want to buy, how many items, how many units. So the supply equation for this particular example is x divided by 80 minus 1 over 20. So that's going to be for supply. And for demand, we're going to have 1,264 divided by x. All right. So find the price of a camera at which supply is equal to demand. So what we have to do is we have to, set these two equations equal to each other. And then find the values for x. Come on. Okay. So different ways to do this. You can use a quadratic formula. Yeah, so the first thing you want to do is you want to combine these two fractions, right? And then you can cross multiply. So if I combine those two fractions, let's see, I'm going to get the least common multiple would be 80, right? 80 divided by 80 is 1 times x is x. 80 divided by 20 is 4 times 1 is 4 equals to 1,264 over x. I'm going to cross multiply this. So I'm going to get x squared minus 4x equals to 1,264 times 80, which is 101,120. Okay, and then let's see what else. If you rearrange this, you're gonna get x squared minus 4x minus 101,120 equals to 0. And from this, we can use the quadratic equation. Yeah. So we can plug the values in. So my a equals to 1, my b equals to -4, my c equals to negative, it's a big number. Let me do it. C equals to 101,120. So if I just plug them in, I'm going to get minus b, so that's 4. Negative times -4, that's plus 4. Plus or minus the square root of b squared, which is -4 is 16. Minus 4 times a is 4, a is 1, so 4 times c, which is this big number, 101,120 divided by 2 times a, which is 2. Okay, so let's put this in the calculator. 16 minus 4 times 101,120. What the heck did I do? Oh, this is negative. My bad. This is negative. All right. I forgot there's negative right here. All right. So square root of 16 minus 4 times negative 121, 101,120, and we get 636. So x equals to 4 plus or minus 636. All of this divided by 2. So I can divide by 2 and I get x equals to 2 plus or minus 100. What? Oh, yeah. My bad. This is right. Okay, so 300 and let's see. So we got two answers for this. 2 plus 318, which is 320. Right? And then 2 minus 318 equals to negative 316, right? This is a negative number. We cannot use a negative number in this case. Okay, because we're talking about number of cameras, so we need positive numbers. Okay, so our x equals to 20 when x 320 when x equals 320. Supply and demand are going to be the same, but that's not the final. That's not the final answer. It says find the price of a camera at which supply is equal to demand. So what I have to do is I have to use one of the equations that we got and find the price. When x equals 320. So I can just use the second equation. Okay. P of 320 equals to 1,264 divided by 320. I should get an electronic calculator. 3.95. Okay. So that's going to be it. This is the price per camera. So when supply is the same as demand, we got the number of cameras being 320 and the price being $3.95. Okay, so that's it for this. Oh, I have one more section. Yeah, equations reducible to quadratics. So I'm gonna do just one example. Maybe I can do all of them. Number 8. Resume. Hey, so I'm back. How do I find though? Number 8. Equations. Maybe I should. Equations reducible to quadratics. All right. So sometimes they might give you a quadratic equation and you can turn it into a quadratic with a little substitution. That's it. So for example, they say they give you this quartic equation equals to 0, and they said substitute let m equals to x squared. So I'm gonna rewrite this in terms of m, so I can do this. I can do x squared. This is the same, right? Minus 10 times x squared plus 9 equals to 0. Now remember this right here. So I'm gonna substitute these with m. So I'll get m squared minus 10m plus 9 equals to 0. And now I can just factorize this. M minus 9 times M minus 1 equals to 0. So I get M equals to 9 and M equals to 1. And then I just come back here, right? And I substitute these numbers with M. So X equals to plus or minus 3. And then we have 1 equals to X squared. And this is X equals to plus or minus 1. And those are my answers. Okay. Let's do number 9. Okay. Oh. We have x squared minus x squared minus 18 times x squared minus x plus 72. So if they don't give you the substitution, you choose your own letter. So I don't know, I'm going to use P equals to x squared minus x. I'm just going to bring that here. So I get P squared minus 18P plus 72 equals to 0. And this simplifies to P minus 12 times P minus 6. Okay. So P equals to 12. P equals to 6. And I go back and plug them in here. So I get 12 equals to x squared minus x. And 6 equals to x squared minus x. I'll just rearrange this. X squared minus x minus 12 equals to 0. X squared minus x minus 6 equals to 0. And then this simplifies to x minus 4 times x plus 3 equals to 0. And this one to x minus 3 times x plus 2 equals to 0. So x equals to 4, x equals to negative 3, x equals to 3, x equals to negative 2. 4, negative 3, 3, and 2. And that's it. Those are the answers. Lastly, we have an exponential equation. So we have 2 to the 2x plus 5 minus 3 times 2 to the x plus 2 plus 1 equals to 0. Okay. So first, I'm going to rewrite this a little bit. So this I can separate as 2 to the 5th times 2 to the x squared. All right, so I separated this expression, and this would be turn into this. All right, because if I multiply them, I'm going to add up the exponents. So this will be 2 to the 2x plus 5. You see, if I add up the exponents, 2 to the 2x, because I have to multiply these two, and then plus 5. And then for this one, we got negative 3 times 2 squared times 2 to the x plus 1 equals to 0. I can, I don't know, let's see, let u be 2 to the x. So we have 2 to the 5 equals to the 5th power to the 5 equals to 32. 2x equals to u, so u squared minus, this is 4 times 3 is 12. 2 to the x is u plus 1 equals to 0. I'm gonna use the quadratic equation for this one. But you know what? Let me try to factorize it. So this is 32. I need two factors of 32. That will give me negative 12 when I add them up. Oh, negative 8, yeah. Negative 8 times negative 4 equals to positive 32. Negative 8 minus 4 equals to negative 12, right? So 32 u squared minus 8u minus 4u plus 1 equals to 0. Factorize the 8u. So we get 4u. 8 times 4 is 32, u squared. I need negative 8u, so just minus 1. From here, I can factorize a negative 1. And this would be negative 1 times 4u equals to negative 4u. I need a positive 1 here, so I have to multiply this negative 1 by a negative 1. Then I can factorize the 4u minus 1, times 8 times u minus 1. And this would become u equals to 1/4 and u equals to 1/8. Okay, now remember that u equals to 2 to the x, so I can just substitute this. 2 to the x equals to 1/4 and 2 to the x equals to 1/8. And solve. So this would be 2 to the x equals to 2 to the negative 2. And then this means x equals to negative 2. This 2 to the x equals to 2 to the negative 3. So x equals to negative 3. Okay, that's it. So these are the two answers for this one. All right, you could use a quadratic equation also, and you should have gotten the same answers, okay? X equals to negative 2, x equals to negative 3. And that's it. All right, cool. So thank you very much for watching. If you're one of my students, please do this. This is your homework assignment. Learning guide. 1 through 3. A, sets 1 and 2. All right. Talk to you guys later. Bye-bye.